Hey, Johan, welcome to Best of Breed podcast, ProptechOS. Really nice to have you here.
Thank you.
Thank you. And Johan Öhrn, you are from SafeLine. You are specialized in elevator, in analytics and collecting data. And I mean, it's really cool. We have been working a little bit together now with a couple of customers, and I'm really impressed about that. I was thinking of that we will be looking at. What makes an elevator tick?
Yeah,
What are the challenges?
I can speak about that. That's no problem. Yeah.
You can. But I mean, just before we start, I mean, maybe you want to say a few words about yourself and SafeLine, of course, which is a leader in elevator safety equipment.
Yes. So I'm Johan. I'm Chief Product Officer of SafeLine, but I identify myself as a lift technician. So that's my past and what I see myself as. I worked with lifts since I was a small child, more or less.
Do you say lift or elevator?
Depends on where your audience are. Yeah, exactly.
Okay.
So,
which is what do you say in Europe?
I think lift is the European word or the English word, and elevator is
the US.
US word.
I got it. We got that one down.
Yes. I'm elevator nerd, working for SafeLine. SafeLine is electronic component manufacturer. Our main product is actually emergency phones for lifts, but we have been working with monitoring of lifts for about 10 years now, trying to get this monitoring equipment that we'll talk about today quite a lot, I think.
I mean, this is not a product demonstration, but we can just say what's quite interesting with SafeLine is, as I see it, is that you have, besides your other product line, but the interesting one is that you both have a specific hardware that you can retrofit and collect traffic data and behavioral data from any elevator, and then you also, of course, have an analytics application, where you can consume data from any elevator. I mean, you have really made this kind of agnostic, as I see it.
Yeah, I mean, monitoring of lifts has been available for 50 years. That's nothing new to monitor how a lift behaves. I think the new thing that we try to achieve is to make it accessible. So that's to make it accessible to everyone, and also to be able to connect multiple type of lifts. You need to have a lot of lifts to be able to gain real value.
And I mean, lifts, I mean, you see them all the time, and the only time you notice them is when they're not working.
Yes.
And that's when you get annoyed.
Yeah, exactly.
But I mean, looking at this, I've been talking to you before. What I think is intriguing and interesting when I started to see the work you're doing is this trying to find, I mean, the patterns.
Yeah. You can either monitor lifts by the signals. If all lifts has a signal, how it behaves and what it's do, but it's actually the pattern that is more interesting, because with a history of the pattern, then you can make a forecast of what is going to happen. So what we are looking at is the pattern, the behavior of the lift. We're not using the signals only, we're using the history of the data.
But you mean the pattern that suddenly one lift starts to taking much longer time between floors? Or
it's how often it travels during certain time of the day, the doors, how they open and close, in what pattern they behave, the vibrations pattern of the lift itself.
Okay, so
from that gives us a starting point of the normal behavior of that lift, and then we can see if that changes.
This sounds like a data science slash statistic analytics / AI case.
Yeah. So I don't really to say that we are using AI, but we are using AI
Mathematics.
in the sense, yeah, it's mathematics. We have had help from a professor actually to build the algorithm inside the units to be able to do this and give us data, because we can't send every data to the cloud. It's then the data volume would be too much. So we use quite a lot of algorithms in the unit itself and edge computing
to pre-process
Yeah.
it and to do that. What are the most common error with the lift, I should say?
I mean, the doors are the most sensitive parts of the lift. It's where the wear and tear happens, and that's accessible to the users also. So the doors are the sensitive parts, and a majority of the faults are there.
Okay, are door related. Yeah, I didn't know that, but when you say it, it makes sense.
Yeah.
I don't know how many times I've bumped in with something when you're moving
And
something, squeezing something into the elevator.
It's modern lifts are really advanced systems.
In the sphere that we are active in is, of course, smart buildings. I mean, how can you connect the elevators, the lifts, I should say? How can you connect the lifts to the other systems in the buildings and to the people using them?
It doesn't matter how much data you have. If it's not given to the correct people, it's a waste of time.
If it's an isolated island of the data, then if you can't cross-use it with other systems. What will the lift of the future look like? If you could design the perfect lift.
I don't think it. I mean,
like in science fiction movies.
The lift is so effective when it's correctly programmed, and when the building is correctly when they built the building and calculated
day one.
When they calculated how many lifts they need, if that is done correctly, there is the efficiency of the lifts are fantastic. It consumes very little electricity. The perfect lift is the lift that are maintained in the correct way. So I think it's not the lift that needs to improve. I think it's how.
And then we come into if you can fix the errors before they happen. I mean, predictive maintenance. I guess that is probably the key to have the perfect lift. But as you said before, and I know when I've been coming across some data from lifts, when it turns out when you're looking at the actual service, the usage of them, then you can see that there has been an uneven distribution. A couple have been running much more. That would point to that the programming wasn't perfect.
Yeah, quite often that the lift parks in different floors. So it's always one of the lift that goes down and park in the entrance floor that will then drive much more than the others. So if that is incorrectly programmed from the beginning, then you get one of the lifts will wear out years before it actually needed to be.
Of course, when the building is new and it's perfectly tuned, and then as we know, a building tends to stand for many years, and it might take 20 years or more before you make a large refurbishment. But I mean, it's still people are moving in and out, and the uses are changed. I mean, wouldn't it be better to have something that adapts and learns that you don't? That can improve the programming.
But I think many control systems already have this. They can learn and see patterns. Okay, now it's in the morning. Most people come into an entrance floors and will go up into the building. Then the group lift can learn this and go down in preparation.
So I mean, I thought I just had a fantastic idea that no one else had thought of.
It's thought of, but not always used though. So in that sense, monitoring could help also to see these patterns. Maybe then help the building owner to see that this lift could be more efficient. But also when there are a lot of traffic, it's difficult to increase efficiency. There we come down to the doors again. Quite often to speed up the door movements is the best way to get more efficiency, because then it's less waste of time where the lift stands still.
Well, efficiency or capacity of lifts, what you measured it by people moved by floor times hour, or people per floor per hour?
It's how much people you can move in a building. And of course, you can measure this in waiting times.
So that's a KPI for lifts.
If we go to a lift and experience it takes too long time, it's how long time you have to wait. Of course, it could be also that you go into a lift and then you need to stop at 5 or 6 floors before you go to the floor you need. And I think that is one of the latest new invention with lift is the destination control. You select which floor you will go to before you enter the cabin.
That's what you see in modern floors. Modern lifts, you select 3 and then
exactly. And
like that.
It's a good idea, but there's always a weak link. And in this case, it's most usually the person that goes in with his colleague into the lift, but intended to go to another floor, and then he needs to go out and press the destination. So it's a lot of, it's not very user-friendly always. True. And that you get irritated customers. People are not very used to use that kind of system, but it can increase efficiency quite a lot.
I mean, looking at other challenges that you see with lifts, I mean, going forward, I mean...
To make it more efficient is to be able to use the predictive maintenance, and that's my goal. It's actually, I try to develop the tools that I would like to have when I was a lift technician. That's my goal. I want to,
If I only have had this.
If I had this kind of tools and the data available to me, I can nerd into lift data. I can sit and look at spreadsheets for a day just to try to understand why the lift data looks.
And why it behaves like it. I mean, when we start looking at smart buildings, cross-reference it with like, if you know that the subway is about to hit, if you have a building or something like that.
One of the things that we look at when we look at the patterns of a lift, and we make alarms. If we see that the lift is not traveling as much as it used to, that's an alarm. But if we then would know how many people have entered the building, and we can see that, not many people are entering today, so then it's not probably the lift that is a problem. It's something else. There's a delay in the subway or
the refurbishment. Might have.
So that would benefit our knowledge about the lift. It is one machine in big buildings.
My take is that you don't really notice lifts until they don't work, and I guess if we're looking from a property owner's perspective, I mean the costs for doing emergency repair or that is
can be enormous.
Probably a little bit higher than if you could have done it on the normal business hours.
Just to know before your customer, that's a key as well. It's so much difference to call your customer and say, I know that your lift is standing still. I've sent a technician there. He will be there in 2 hours.
4 o'clock.
But we know about it. Instead, the customer calling 15 minutes later saying, I want the people, he'll be there in 2 hours. The outcome is the same, but the experience for the building owners is so much different.
True. I guess when I have seen this kind of top 5 complaints from tenants, it doesn't matter what kind of business you are in as a property owner. It's usually, I mean, lifts are definitely on that top 5 list. I think I've learned very much new things that I thought, I've seen lifts and I've seen data and connections to them. How hard can it be? But I do understand that there's much more you can do. So I would just say thank you very much, Johan.
Thank you
for coming here. It was a pleasure to have you here. I would just say that thank you everyone for listening to this, and I mean the contact information to me or to Johan will be below this video clip. Don't miss out to see the next episode of ProptechOS Best of Breed. Again, thank you, Johan,
Thank you.
and thank you, the audience.